ጤና ይስጥልን እንደምን አላችሁ? ይህ የስልጠናችን 7ኛ ክፍል ሲሆን በዚህኛው ስልጠና ላይ የራስተር ዳታን ወደ ቬክተር ዳታ እንዴት መቀየር እንደምንችል በQGIS እናያለን። ወደ ቪዲዮ ኦኬ In the last video we have seen how to delineate watershed or catchment by using digital elevation model in QGIS. And in this video I am going to show you how to convert raster data to vector data in QGIS. And I have for now land use land cover raster data type, and this land use land cover raster data will going to be converted to vector data. So this is a process to convert raster into vector, which means vectorization. So especially the conversion of raster data to vector is called as vectorization in GIS. This process is very useful for a variety of geospatial applications such as land use land cover mapping, hydrological analysis, and geospatial data modeling. Now let us see the data type, which is land use land cover in raster form, as I have said, and this one is classified by using Google Earth engine. I will come also with another video how to classify land use land cover by in the Google Earth engine. For now, this land use land cover is from the Landsat 7 data set, and it has the resolution of 30 meter, and the date, the acquisition date is from the year 2014, and averagely 1 year image, and it has, as you know, it has the scanline error, and this scanline error is also corrected by using Google Earth engine. Now let me check the properties of land use land cover from the information. As we know from the previous video, we can check here is the pixel size is 30 meter by 30 meter. That means resolution is 30 meter, and the coordinate reference system is the projected coordinate system, UTM zone 37N, and the unit is meter. Now let's see the symbology part, and here, as it is raster data, I have to change the render type to single band pseudo color. Then I can classify it as we see here, the 8 classes. There is 8 different land use classes, so I can classify it in this part like this, 8 class, and I can do like this. And if I want, I can do what this part is mainly no data value. I can limit this one in transparency as we have did in the previous. So I can assign 0 for no data value. Then I can do apply, and okay, so here is so there are 8 different classes of land use land cover. Now this one is in the raster form, so I have to convert this one to vector, or I can also classify the classes, each class, by using the interpolation in the discrete part. Then I can assign 8, then I can give the value for this one 1, okay, 3, okay, Okay, I can customize, and here is 8 different classes. So this one is in raster format. That's it. Now let's go to convert this one. Go to raster, then select conversion. From the conversion, you have to select polygonize. That means raster to vector. So here is the only thing that I do is I can select here. The input is land use land cover 2014, and other things are no need of change. Then I can give the name for the output, and I have to save it in my specific folder where my workspace is. Okay, I can give the name. Here is the save as type is shapefile, so I can give here lu lc lc 2014. Okay, then I can hit run. Yes, now converted to vector form. Now let me uncheck this one. First thing is we have to check the attribute table. Here, right click, open attribute table. Here is, as we have said, the classes are 8, but there are many different classes. That means for class number 1, there are many number 1. Those indicate what the specific land cover type. Now I have to check in properties. I have to change the what the symbol or symbology part into categorized. Then the value is dn. Then I have to use the random color, and I have to classify. Here is, so this number 1 is no data, but we have as assigned in the raster no data value is 0, and the others are the class from 1 to 8. Now let me apply. Let's see. Here is number 1 is what no data value. If I uncheck this one, here is. So I know the classes what number 1 indicates, number 2 indicates. I can assign them from, as I have said, from the Google Earth engine. I have to get the information from the Google Earth engine, and I have to assign their respective names. Then I have to remove this one also in the attribute. This one 0. I can select this all, and I have to delete this one by opening toggle editing. Okay, delete. Yes, now here is no. Okay, I have to save it and off. Now if I refresh this one, here is no. I can delete this one. Then I can do, if I want, I can change the color here. For this one, let me use dark black color. Okay, and for this one, let me use red color. I know this is settlement. Okay, and third one is water. Let me use blue. Okay, and this one is forest. So let me use dark green. Okay, this one is shrub. Okay, it's almost green, but light green. Sixth one is grass. Okay, and this one is barren land. Okay, and the last class is agriculture or cropland. Almost I can use blue. I mean yellow color. Agriculture, yellow. Okay, then apply, and let's see. here is. So now we can okay. Let me one step on this one, which is dissolving. Dissolve. Let me dissolve this converted land use land cover. Now the input is land use land cover 2014, and the dissolve fields are what distant number dn with respect to dn. Now I have to give the file name in the specific workspace lu dissolve. Okay, then hit run. Okay, yes, it was dissolved. Now I can change the symbology. Here is categorized and value is dn. I can use random number or random color, and I can apply now. Here is, and I have to check the attribute table of this one. Here is only 8 classes, 1 to 8, and the last undissolved one has, here is many ones and many twos. So you see there is the difference between dissolved one and the undissolved vector data. So thank you very much. Don't forget subscribing my channel, and I will come with other video